Hello, my name is Ilya Sychev, and I'll give you two lectures on a database in this course. Here you can see my email address. In case you have any questions regarding these two lectures, please write me. Today we will talk about data itself. Then we talk about database management system and why we need them. Then we see entity relationship model and databases. Then we talk about structured query language, and I'll give you some example how you can use it. Also, I would like to mention that it's not enough to cover the topic called databases, and we need separate course for that. But after these two lectures, I think you will have some rough ideas how you can use it in your work or in your study. Okay, let's talk about the data. And here you can see the statistic for 2019, how much data user produces in just 1 minute. For instance, we can see here the number of Skypes, how many calls user make via Skype, or how many searches Google contacts in just 1 minute, or how many photos user posted to Instagram or stories to Instagram. And also we can see here the growth of global internet population. So this means that data never sleeps. So we see growth and growth in the future. And we can see also the growth of IoT devices, and in 2006 it was just 2 billion, and in 2020, in this year, it's 200 billion of devices. So this means that we have a 10,000% of growth during these years. And if we divide this amount on human population, we got that on every human we have 26 smart objects. And it's interesting where this smart object is. Here you can see the statistics, how these IoT devices, smart devices spread. Most of them are in business and manufacturing, major part in healthcare, also some in retail, security, and so on. This means that we have a tremendous amount of data, and there is some challenges comes with that. So we need to, if we deal with this amount of data, we need to keep it organized. And the bigger the amount, the more important organization become. Also storage, how to store this amount of data, data persistency, and if something happens, I want that my data still be there. And also efficiency of working with this data, update, retrieval, and so on. Also concurrency, if we do some multiple operation over this data, and also decoupling the application using the data from the system managing the data. So this means that we have a layer with application which process the data, and we have the application, separate application, which is responsible for managing the data itself. And to answer to these challenges, database management system was introduced. Now we can talk about the database management system and what it is. And it's, if you look to the database, it has three schema architecture. And on the top, we have external level, and this is what end users see. Then we have a conceptual or logical level here. Then we have an internal or physical level here. And what does it mean? External or view level, this is the highest level of the database abstraction. External or view level describe the actual view of data that is relevant to a particular user. Conceptual or logical level describe the structure of the whole database. And this layer acts as a middle layer between the physical storage and the user view. And the database administrator and the programmers work at this level. And internal or physical level, this is the lowest level of the data abstraction, and it describes how the data is actually stored in the database and provide methods to access data from the database. Here we can see some main characteristic of database management system. and data stored into tables. Data is never directly stored into the database. And also DBMS allows to have relationships between tables, which makes data more meaningful and connected. Also, it helps reduce redundancy, and it uses normalization technique to reduce the repetition, and also it provides data consistency, support multiple user and concurrent access, also provides some query language, and we talked today about structured query language, which is for relational database. Then also it provides security and manage access to the data, and also it supports transaction. And let's talk about transaction in detail. Transaction is a unit of work executed to retrieve, insert, remove, and or update data. And to meet the challenges listed before, a database management system must ensure four properties to every transaction. And it's first atomicity, second consistency, third isolation, and fourth durability. And the abbreviation is called ACID, and we talk about each of them in detail. First, atomicity, and this means that transaction, even those requiring multiple operations, are executed as atomic entities. So this means that either all the operation in transaction succeeded and the changes committed to the database, or the full transaction fails and leaving the database unchanged. And to illustrate this, we can see this example. For instance, we have an account A, and we want to take some amount of money from this account and put it, divide it to two different accounts and put it there. And let's assume that we get the amount of money, and but then we have a power outage on this operation, and then next two operation will not execute it. So this means that if atomicity not guaranteed, it means that we lose this amount of money from account A. Second is consistency. This means that each transaction must bring the database from a valid state to a new valid state. And for instance, if you want to transfer amount X from account A and put it to account B, it's not put as, for instance, X minus 1 to account B. So this means that it's consistent. It keeps consistency. Third is an isolation. An isolation ensures that if multiple transactions are executed simultaneously, the effect is the same as if they were executed serially. And the last is durability. This means that all the transactions that successfully come to completion are stored in the database in a non-volatile way, even in the case of system failure. Okay, let's talk about databases. Database is a structured collection of data organized according to a specific data model. A data model is a high-level description of the data, and today we focus on the relational data model. That's why it's called RDBMS, Relational Database Management System, and I'll show you some famous vendor later. Now we come to entity relationship model, and entity relationship model describes the structure of a database with the help of a diagram which is known as entity relationship diagram. And when we design a database, we might have first analyze the requirements, everything what we might need for the definition of the model. Then we made a conceptual design and we define a high-level description of the data to be stored in the database. And the last step is the logical design. So we translate our conceptual design into a database schema expressed according to the data model of the chosen DBMS. And this is important because different DBMS has a little bit different database schema definition. So we need to adapt our entity relationship model to specific DBMS. And what entities means? So entities in ER model is object from the real world. Like bank account, employees, meetings room, buildings, sensors, and so on. And then the relationship, and this is association between two or more entities. And later on, with an example, you can see how the relationship defined. And there are four types of relationship: one-to-one, one-to-many, many-to-one, and many-to-many. entities are described by attributes. So each attribute represents a property useful for the database purposes of the entity it's related to. Each attribute has a domain. Domain describes the data type of the attribute. For instance, integer for numbers, or 20-character long strings, or date, or other data type. And for each entity, there is a subset of attribute which uniquely identify this entity, and it's called primary key. So here we see an example of building, and for building we have an ID of this building, and this is will be a primary key. Then we have a number of floors, then number of flats, the address, and the GPS point for this building. Furthermore, relationships model association between two or more entities, and relationship may have descriptive attributes, that is, attributes that specify the nature of the association. For instance, here we see the building from previous slide, and then we have also sensors, another entity, and it has ID, type, location, and transceiver. Then we have an association called monitors, and this association has attribute, additional attribute which define this association. Okay, we talk about entities, we talk about relationships, and now let's go through the process how we define first entity relationship model, and then how we can convert it to the relational data model. So let's go from point by point. Entity relationship model is useful for obtaining a high-level description of the process via modeling. So we have some real objects, for instance. It could be some bank, or it could be some like a sensor network, and we want to create a model for that. And first we build this entity relationship model. Once this step is completed, then ER model has to be translated into the framework of the DBMS of your choice. So this means that it will be specific for each DBMS. Then, when translating an ER model into a relational one, entities and relationship are mapped to the tables. And entity is mapped to a table with the columns, the attributes of the entity, and keys, the keys of the entity. And relationship with no constraint is mapped into a table with columns, the attributes of the relationship, and the primary keys of the entities that the relationship connects. And special attention must be given to the keys, so that the primary key of the table is the concatenation of the primary keys of the entities, and the primary key of each entity connected by the relationship serves as a foreign key for the new table. And here we see our ER model, and then let's talk how we convert this our entity and our relationship to a table, and how it's represented in a database. So our building, this is an entity, and it's we will create a table for that, and it has properties mapped from the ER model. So we have ID for primary key, so we have GPS, number of floors, number of flats, and then here you can see the data type for this for the property. Then we have the same for sensors. We have ID, this is a primary key, we have location, type, and transceiver. And also we see how we convert the monitors, our relationship, to also to the table. And we get building ID, and we got sensor ID. As you remember that the primary key, this is a unique identifier for entity. So that means that for unique building, for one unique building, we build a unique relationship between the unique sensor. So, and we put it here, and we don't put all this data to the table of for the monitors table. So we just need to get ID, and then if you want to get building properties, if you know the ID for the building, we can get other properties from building table. the same with the sensors. And then if you want to add some extra properties here, we can also do it here. So it's you can see how we define this table. Okay, and we also can refine our model, and here you can see how we change it. So a sensor can monitor at most one building. So this is a key constraint for the relationship monitors, so that we don't put the same sensor to two different buildings, and it's indicated by an arrow on the line connecting the involved entity to the relationship. So we can see how it's modified now. The table building stays the same, but we put the properties for building ID and the frequency to a sensor table, and we extend it to that. So we see here it's called foreign key, and it's related to the building table. And also we put the property frequency here, and we define it as an external, as one of the property for the sensor. To summarize what we just learned here, first we need to define entity relationship model based on our requirements. Then we convert it to specific database management system, and also we can apply normalization for database, and we not covering it here, but for your information, it's the process of structuring a relational database in accordance with a series of so-called normal forms. If you want to know more, so you can Google database normalization, and so this is basically it. There are some well-known relational database management system. Maybe you already heard about them. MySQL, PostgreSQL, SQL Server, SQLite, and so on. And it's not only for you. If you go to the site, which is called dbengines.com, you can see that it's more than 140 DBMS, and you can see the ranks of popularity of that relational database. Okay, we come to our last part of the lecture, and here we talk about structured query language and how you can use this structured query language, and you can define your table and relationship, and also how you perform queries on the data. And I'll show you a platform which you can use for running your model and check your model. So let's go. Here you can see the query for creating a table, and it's in structured query language. You need to write it like this. So you create table, then you put the name of the table, then in brackets you define with the separation of comma, you define the properties. First it go the name of the property, then you define the data type for this property, and the same for the sensor table. And important thing here, we add column called building ID with the property int, the same as the ID here, and also we define that foreign key, that this property will be a foreign key for this table, and it's reference to building ID. So this is important part here, that we create a relationship between sensor and building. And what does it mean? This means that for each building we can define multiple sensors, and it's called one-to-many relationship. Here you can see how it's defined in ER diagram. So you have a building entity, you have a sensor entity, and then you have a relationship. And this building ID, it's a foreign key for table building, and usually it's using this abbreviation. So you put your table name, and then underscore, and then ID for the primary key, name of the primary key in a table which you associate with. Once you define the table, you would like to put some data there, and for that you can use another query. It's called insert, and it's written like this. So insert into, then you say to which table you want to do this insert. Then you can also list the set of values, set of columns which you want to set for this row, for this data. Then you say, then you write values, and then in brackets you listed the properties, and it should be so for address it should be on the first place, for GPS coordinate should be on the second, number of floors on the third, and so on. And the important thing here that for instance address we're using string type, and we put this here the quotes for the string, and for int data type we don't need to put anything, so it's just a number. So this is important. Once we define building, we also would like to add some sensors for the building, and we can do so the same way. And I would like to point at you that we also put here the building ID, the value for our foreign key, and we assume that first two building will have 1 and 2 building ID, and it's you can see it here. So the last value here, and yeah, if you put here not existent building, for instance 1000, but you have only 2 and you don't have such a building ID, you will get an error. To retrieve information from table, you can use another query, select, and it's written like this. So if you want to get all buildings, you can write this query. If you want to get all sensors, you can write this query. And if you want to join and to see which sensor relate to which building, you can use our foreign key for that in table sensor, and you can create a inner join for that, and it's written like this. So you select building and all property for building, and then you can also define what you want to get from table sensor, and then from sensor inner join building, and then you can write the definition for your joining. So, and then we join it via this attribute building ID, and then we want to associate it with the building ID. In case you want to delete some data, you can use another command, another query, delete from, then you define the table from which you want to delete, then you create a condition based on which you want to delete. And I would personally recommend you first select from the table based on this condition, and you can see exactly what you will remove, and then only after that you apply your delete. Also, if you want to drop whole table, you can write this this query drop table, and then define the name of the table. And the important thing here, if you have a relationship, as we define it here with the foreign key, in case you have some data, it wouldn't be possible for you to remove. For instance, if we have some sensor associated with the building and I want to drop the table building, I will get an error because I have some data which associated with that, and it would be impossible. Yeah, database wouldn't allow me to do so. Structured query language has a lot more queries and a lot of more topic for discussion, but this is out of the scope for this lecture. And but you can go here to these resources, and with very nice example you can learn structured query language. And I'd recommend you not just read the tutorial, but apply these to real database. So once you learn something, you can try it with a database, and you can see and you can get much more from that. Now we go to website which is called SQLfiddle.com, and the good thing about this site, so that you can choose different database management system. So here you can see the list. So we are choosing PostgreSQL, and you can build your schema here, and you can run your queries here, but you don't need to install anything to your PC. So this is a good thing about this website. So you can try just very easily. And first of all, we will build our schema. I'll copy it from the lecture. So, and here we define our two table, building and sensor, and then let's try. Okay, successfully created. Then we can see in browser, browse our schema. So we see the table building and table sensor. Okay, good. Here you can put your queries, and I will use the queries from our lecture. So first we put buildings, then we will run select query to see what we have in a table building. Then I would like to add sensors for the buildings. So, and we define like 3 sensor for building 1, for building for building 1, for this Georg Schumannstrasse 11, and then 3 sensor for another building. Okay, then let's also run some select from sensor and see what we have in the table sensor. And also this is inner join between two table, building and sensor, as we discussed before. And let's see what we have in this association. Once we define all queries which we would like to execute on this schema, we can run all of them, and then let's see what we got here as a result. So here you can see the output of the command select building. Here you can see two rows in the data in the table building, sorry, and then this green line indicate the so each green line for each insert, and then we can see the output of the of this query select from sensors. This is the list of our sensors here, and at the end you can see the result of the last select statement here, and it's show our, based on our relationship between building and sensor, it showed the data, and so this define our building. This is comes from our building table, and then this data comes from sensor table, and it's associate. So these 3 sensor relate to building 1, and these 3 sensor relate to building 2, and this is how it works. And this is it for today, and see you on the next lecture.